Okay, welcome. In this video, we're going to look at SAT Worksheet 203, Data Collection and Analysis. Out of 58 problems, you'll see maybe 2 on this category. These problems are really easy to miss, though, if you're not familiar with some basic principles in polling, data collection, and statistics. This worksheet pairs nicely with Worksheet 212, so I would definitely recommend doing that one first, especially the second half of it before doing this worksheet. But anyway, we are going to get right into this one. So there are 3 parts to this worksheet. We're going to look at problems that test you on sample bias. We're going to look at problems that deal with sample projection, and last but not least, margin of error when you take a sample. So let's start with sample bias. Okay, so there's plenty to read here, and I kind of gave an interesting case study, which you can kind of read on your own. But let me start with this idea. Pretend that you're conducting a survey for your school. Your school has a population of, let's say your school's population is, we'll say it's a really large school. We'll say it's 4,000 students. And all you want to figure out is you just want to figure out whether or not people prefer apples or bananas as part of their lunch meal. So it's just an apple or banana thing. You don't have enough time to ask all 4,000 people what they want. So you're just going to randomly survey 100 people. So you're going to do a survey of 100 people. Let's pretend the way you do it is you get to school super early, and the first 100 people who kind of come to the door of the school, you ask, would you prefer to have an apple or a banana with your lunch on a day-to-day basis? And let's just say that 80 say bananas and 20 say apples. So you would say, okay, I think it's very likely that about 80% of the whole population would prefer bananas. Okay, my question for you is, why can't we say this? Why is the way you went about collecting your data, which is you just asked the first 100 people who showed up to school whether they'd want an apple or banana, why is the way we went about collecting the data, why is there sample bias? Why is it flawed? And you can pause and take a moment to think about this, but I'm just going to kind of reveal reasons why there's sample bias or this is flawed. Okay. First thing is our sample is meant to project the 4,000 students as a whole. Well, maybe most of the seniors don't have to show up right at 8 a.m. in the morning for class. Maybe they're able to take later classes. So maybe your sample is just a lot of eager freshmen who show up early. So your sample doesn't really project the student body as a whole, and more projects what freshmen think. So that's one thing that could have happened when you just asked the first 100 people, is maybe the earliest people who show up all tended to be a certain class. Or maybe what happened is out of the first 100 people, let's just say 90 of them were female, but the school is 50% male and 50% female. So again, we kind of have a very biased example there. It's not representing both genders within the population. So the big thing we want in order to avoid sample bias is we want to make sure that the group that we select is representative of our population as a whole. How do we do that? The key word is randomized. It needs to be, and this is a word you want to look for over and over again, but it needs to be a randomized selection. It can't be volunteer, because people who volunteer may have a strong opinion about apples or bananas one way or the other. Maybe, you know, the people, 80% who said bananas had a terrible experience with apples early in life. So it can't be volunteer, because then people are self-selecting. That's why the ratings on Amazon are skewed really high and really low, because most people who choose to actually rate have had either a really positive or really negative experience, but they're volunteers. So the ratings on Amazon don't actually reflect what the majority of people think. The Amazon ratings have tons of sample bias, ironically. But anyway, if you were to think about this one, you would have to just randomly select from all 4,000 students. That random selection would give you a kind of a snapshot of the entire population in a way that avoids any sample bias or flaws. So not until you do that are you actually able to extrapolate your data to all 4,000 of the students at the school as a whole. So this 100 student survey would have to be a randomized survey of all, the 100 students would have to come from the entire population, all grades, all genders, in order to reflect the population at large. Anyway, let's look at a tricky one here. I kind of made up this example from a problem I saw on the test in the past. A researcher hypothesizes that consuming 1 tablespoon of olive oil each day reduces the risk of heart disease in 50 to 70-year-old men. 100 men who already consume 1 tablespoon of olive oil each day volunteer to be in the first group, and 100 men who do not consume 1 tablespoon of olive oil volunteer to be in the second group. So already I noticed we have some volunteering here, so that could be problematic. After 5 years, the researchers find that the 100 men who consumed olive oil were 50% less likely, so group 1 was 50% less likely to suffer from heart disease. My question for you, and take a moment to pause the video and really think about this, is why can't the researcher make the claim or assert that olive oil likely, not definitely, but likely reduces heart disease? What flaws are there in this experiment? Why is there sample bias? So I'll just continue kind of pointing out why there's sample bias. Well, one is you didn't get a random group of 200 men and just randomly select half into one group and half into the other group. So that's one reason why there's sample bias. If you think about it, the 100 men who volunteered to be in group 1, maybe they're all men who cook for themselves. So they cook and they like to cook with olive oil, and maybe because they cook for themselves, they're very conscious of what they eat. And because they're very conscious of what they eat a healthier diet. So maybe these men who use olive oil, maybe the reason why they're 50%, group 1's 50% less likely to have heart disease, maybe it has nothing to do with the olive oil. Maybe it just has to do with the fact that they cook for themselves with olive oil, and because they cook for themselves, they're cognizant of what they eat. So healthy food. But the fact that they cook for themselves healthy food has absolutely zero to do with the olive oil. So there are too many. When you let people choose what group they're in, when you don't do a randomized trial, essentially there are too many other factors that could be the reason for your output or your results. You need to know that your dependent variable, the reduction in heart disease, you need to know that that output is a result of the input, in this case, having olive oil or not having olive oil. And the only way to really know that is to get as many men as possible and randomly select them into 2 groups. And then you have a better sense, because you're controlling the stage, you can make sure that, that the only major difference between the 2 groups as a whole is the olive oil. But when there's volunteers, there could be other major differences at play. So you always have to kind of be cognizant of letting people choose, because there are certain biases that tend to arise. And you can read more on that below. But let's do some problems. Okay, so let's figure out why this first one is biased. So a city parks department, I'll make this a little bigger. A city parks department currently offers a ceramics program and a basketball program. The parks department director is considering offering a soccer program. So he or she wants to offer a third program and wants to determine how many city residents would sign up if the soccer program was offered. Which of the following groups would be the best sample for the survey? Okay, so essentially, we have to see what this person's trying to figure out. So he wants to determine how many of the city residents. So his population at large is the city residents as a whole. So his sample needs to not have bias, and it needs to reflect city residents as a whole. So let's see what we have. 100 residents of the city who are currently enrolled in the ceramics program. Well, if you're currently enrolled in the ceramics program, you may not be into sports. Who knows? But if we're trying to project towards city residents as a whole, we can't just pick people enrolled in one program. 100 members of a park district soccer program in a neighboring state. All right, so neighboring state, whoa. No way you want to look at a neighboring state if you're just trying to understand your city. You need to be sampling people from your city. 100 randomly selected residents from the city, 100 randomly selected residents from the state. So we want randomly selected residents from the city. 100 randomly selected residents from the city will best reflect what the members of the city would think as a whole. The state could totally change things because people in the state could come from other cities with other opinions. So it just wouldn't best reflect that city. Okay. We'll look at one more real quickly. I'll read this one aloud. 100 Park District members will be selected to participate in a survey about selecting a new Park District coordinator. Which of the following methods of choosing the 100 members would best result in a random sample of members of the Park District? So we need a random, unbiased sample that best represents the members of the Park District. So let's see what we have. A is obtain a numbered list of all Park District residents, Park District members, because we want a group of members. Use a random number generator to select 100 numbers from the list. Give the survey to those 100 members. So this seems very random. It seems like our sample is of members only, which is what we want, which is what we're projecting out towards, yeah, this would best get us 100 members randomly. But let's look at these other options. Obtain a list of all Park District members sorted alphabetically. Give the list to the first 100 member. Give the survey to the first 100 members on the list. This is problematic because say that there are like 10 families that are all members and they make up, you know, I don't know, the Ashkenazis and the I don't know, Bogajans, if you want to make up a last name. Let's just pretend they you know, they make up the beginning of the list, and those families feel a certain way. Maybe they want to elect their own member of their family. So taking the first 100 members alphabetically doesn't give us a good random sample. Tell all Park District members that volunteers are needed to take the survey. Again, volunteers is problematic. Volunteers tend to feel strongly one way or another. We need to randomly select people, even those who are shy and may not speak up. D, obtain a list of all district park members who are attending an upcoming event. Well, the upcoming event may be, I don't know, hosted by one of the hopefuls, one of, you know, person who wants to be the next park district coordinator. So maybe everyone who attends that event is a fan of that person. So again, that's an issue. We need A because it's completely random. Okay, let's quickly go to this next part. So sample projection. So we talked about this a little bit, but the sample that you take needs to be projected out towards the population that you're trying to make an estimate of. So if you're trying to figure out how people in Arizona as a whole are going to vote in the next election, you can't just ask one city in Arizona. You can't just ask a geographic location outside of cities. You can't just ask men over 40 or women under 30. You need to get a randomized sampling of people that best reflect all residents of Arizona. So let's look at a quick example here. It says, at a large college of students working toward a degree in English, 250 were selected at random and asked how many books on average they read each month. So we're at a large college, and we're taking from students working towards an English degree. The results of this survey can best be generalized to which of the following? All students at the same large college? No, because we only asked those with English degrees. So it's not all students. Any sample of 250 students at the same large college? Again, no, because it can't be any of the 250 students. We grab just English degree students. All students working toward a degree in English at any college. Well, not any college. If we wanted to reflect any college, we would have had to grab 250 students from across different colleges. All students working toward a degree in English at the same large college. Yep, because our sample is English, and it's from that specific college. So that's what we can project our sample out towards. Okay. I picked one problem on this section that tends to get a lot of people. It's particularly hard. Actually, we can do two. I'll go quickly. We'll do 11 first. Okay, we'll do it kind of fast so we can do the harder one as well. Okay, a polling agency recently surveyed 1,000 adults who were selected at random. That's what we're looking for, from a large city. So they're selected from one city, and they're asked, "Are you satisfied with the quality of air in your city?" 78%, so 780 out of this 1,000 group of adults responded that they were satisfied. Based off of the results of the survey, which of the following statements must be true? Has to be true. Okay. Of all adults in the city, 78% are satisfied with the quality of air. We have no way of knowing that unless we ask all adults. A sample is never a definite. So although we got 78% on our sample, that means we'll probably have roughly close to 78% when we ask all adults if our sample is a good sample. But there's no way of knowing we'll have exactly 78% unless we ask everyone. So the absolutes are always off the table when you're talking about a sample. A sample is always just an estimate. It's a snapshot to try to project out towards the whole. Okay. 2, if another 1,000 adults selected at random from the city were surveyed, 78% of them would report that they are satisfied with the quality of air in the city. Again, we took a snapshot of 1,000 adults. There's no way to say that our 1,000 adults is exactly what any other snapshot would say. So this one's off the table, because just because one group of 1,000 adults felt that way doesn't mean the next group is going to feel exactly the same way. They'll probably feel close if our sample is good, but no way of knowing that we'll get exactly 78%. If 1,000 adults selected at random from a different city, all right, so already that's way off, because I'll keep on reading, but 78% of them would report they are satisfied with the quality of air in the city. So there's no way we can survey 1,000 people in one city and then make a projection towards another city. So in this case, our sample gives us an estimate of how people in the city in this city as a whole may feel about air quality, but we don't know for certain exactly what everyone would say. We don't know for certain what another random group of 1,000 people would say, and we definitely can't project out towards another city. Okay. So 16 is a tough one. 16, there's a lot of noise and it tends to confuse people. So we'll do this one together. If you want to try it on your own, you can just pause the video. But anyway, for the finale of a TV show, viewers could use either social media or text message to vote for either of their 2 favorite contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of the viewers voted. All right, let's just say 100 viewers voted. So there's 1,000 viewers, 100 voted. Whenever you're dealing with percents, always easy to make the number 100. So 100 viewers voted, and 30% cast their votes on social media. So 30 votes are social media. I'll put SM for social media. And 70%, so 70 votes, if 30% is social media, then 70 votes are happening via text message. Okay. Contestant 2 earned 70% of the votes cast using social media. So let's figure out contestant 2's votes. So 70% of social media is just going to be 0.7 times 30. So 30 times 0.7. We're looking at 21 votes. So contestant number two gets 21 votes from social media. Contestant 2 gets 40% of the votes using text message. So 10% of 70 is 7. So 40% is going to be 7 times 4, because 10% is 7, so 28 votes. So tough break for contestant number 2. Contestant number 2 had 49 votes. So contestant number 2 just lost. Contestant number 2 had 49% of the votes, or 49 votes if with our made up number of 100. So let's see based off of what we know, let's see which of the following is an accurate conclusion. So if all viewers had voted, contestant 2 would have won. We have no way of knowing what the other 90% of viewers would have done. So A is off. Viewers voting by social media were likely to be younger than viewers voting by text message. Can't make that assumption. We don't know. There's no way of knowing that. I know you're thinking, yeah, that probably makes sense. Younger people are on social media. There's just no way of knowing it, and you can't make an assumption. It has to be what you know, not what you can assume. If all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. A lot of people pick C because it looks very attractive. Contestant 2 did do a lot better with the social media votes, without a doubt. So a lot of people would logically say, oh, well, if more votes had been by social media, contestant 2 would have won. Actually, out of all those who voted, Who's to say that those who voted by text would change their mind just because they're going to vote by social media? There's no way of knowing that they're going to flip their vote just because they vote through a different medium. So C is actually gone. And let's look at D. Viewers voting by social media were more likely to prefer contestant 2 than viewers voting by text message. Well, that we can very safely say, because out of all those who voted by social media, 70% voted for contestant 2. So D is very straightforward and very easy to support. C is a dangerous assumption that you just have to be careful with. Okay, let's go to the next section. So we covered this on worksheet 212. And if you've watched that video, you've already heard me talk about margin of error. What I'm going to do is I'm just going to get right into a problem, and I'm going to use the problem to explain margin of error. So we did do this problem on the other worksheet, but I'll quickly run through this again if you haven't seen worksheet 212. So a bottling company sells bottles of water. A random sample of 50 water bottles found that the bottles on average contain 0.96 liters of water. And the estimated margin of error is 0.08 with a 95% confidence interval. Which of the following is a reasonable claim to make on the sample? Okay, so let's unpack what margin of error is. I'll briefly talk about confidence interval, but it's not something that you necessarily have to know for the test. Margin of error is this. We only took 50 bottles off the line. They could do over 1,000 bottles a day. So whenever you have a sample, whatever you get to be the average in the sample isn't necessarily the average for all the bottles in that day, for the population at large. So what you do is you calculate something called a margin of error. You will not need to know how to calculate it, you just need to know the concept. So in this case, the margin of error is 0.08. So that's going to bring us up to 1.04 liters and 0.88 liters. So the margin of error, we go up and down from the average that we got. So the average in the sample is 0.96 liters. What we're saying is we think, based off of our margin of error, that the average for all of the bottles for the day would be within this range of 0.88 liters to 1.04 liters. So our average was 0.96. We think the average as a whole will be this close to the average that we got in our sample. Do we know for a fact that the average will fall within this range? No, because we'd have to, again, test all the bottles to know that for certain. But we are estimating that. We think it is likely. That's what margin of error means. And we're 95% confident that we're right about this. 95 out of 100 times we think that the average weight for all bottles for the day would fall within this range. So let's look at these claims. The company always fills its bottles with less than 1 liter of water. No, because we think that the average could even be above 1 liter of water. So A is gone. The company usually fills its water bottles with between 0.96 and 1.04 liters of water. Again, no to that, because our average could easily be below 0.96. And even on top of that, we could be, to get an average of 0.96, we could be filling half our water bottles at, I don't know, let's say 0.80, and the other half at 1.12, right? So again, just because you have an average doesn't mean all of the bottles are clustered around your average. If you think about back to the other worksheet, standard deviation, just because you have an average doesn't mean all your data points are clustered around your average. So a lot of the bottles could actually be far away from the average. D, it is plausible, meaning possible or likely, that on average the company fills its water bottles with 1 or more liters of water. So plausible meaning possible, yeah, it is possible that the average could be above 1 liters of water, because that's within our margin of error. And our margin of error estimates that anywhere from 0.88 to 1.04 could possibly be the average. Okay. We'll do one margin of error question, and then that will be it for this worksheet. And or it for this video, and then you'll be off to try this worksheet on your own. So a big part of margin of error is the larger your sample size, the smaller your margin of error. The more confident you are that whatever numbers you got are closer to the actual representation of the entire population. So the more people you ask, the more bottles you sample, your margin of error is going to shrink because you're going to feel more confident in your data. Okay, so 2014 Gallup Purdue Index report describes a survey of people with an associate's degree and a survey of people with a bachelor's degree. It was reported that in the sample study, 50% of the associate's degree holders and 54% of the associate's degree holders and 57% of the bachelor's degree holders work full-time for an employer. The two statements below are included in the report. So for the results based on the total sample of associate's degree, the margin of error is plus or minus 0.38. For the results based on the total sample of bachelor's degree respondents, the margin of error is much smaller. So assuming the margin of errors are calculated the same way for both samples, which of the following statements explains why the two reported margin of errors are different? So why would these margin of errors be different if we calculated everything the exact same way? Well, essentially, group 2 would have a larger sample size. The larger sample size shrinks the margin of error. So if you look at this, the sample size of the associate's degree sample was smaller than the sample size of the bachelor degree sample. C is absolutely correct because as the bachelor's degree sample, because that one is larger, the margin of error is smaller. We'll look at the wrong answers though. The samples might not have been random samples. I think it tells us straight up that this was a randomized trial, does it not? It does not tell us whether or not these were random, but whether or not it's random won't affect the margin of error between two studies if they're done the same way. There are more people with an associate's degree than with a bachelor's degree. Again, the number of people doesn't matter. What matters is the size of the sample, right? How many of these people we ask. So the number of people with one degree over the other really doesn't affect our margin of error. It's really just the sample size, how many of these people we ask. And then D flips C. The sample size of associate's degree sample was larger. Well, a larger sample size means you should have a smaller margin of error than the sample size of the bachelor's degree sample. Okay. Anyway, I hope this video is helpful. Good luck with 213. If you can get through these problems, then out of the 58 problems, there are 2 more that you'll feel very confident in. Shouldn't take long to get through the worksheet and easily will earn you back 2 problems every test. Good luck, and as always, feel free to come back for more videos.